Attention! Welcome to Polynomial Bootcamp, soldier. Think you've got the grit, the mettle, the stamina it takes to tough it out? Only one way to find out. Let's get right on into our 8th class of Unit 7, Simplifying and Factoring Polynomials Redux. Now you've got a problem set to complete for me tonight, which means that this video is entirely optional. You do not need to watch it, nor do you need to take notes. However, it's here for you if you'd like a little bit of extra practice. Now, I, per usual, am going to keep going. I'm not going at any point to tell you to pause and work these out yourself. But you are encouraged to stop, give each of the problems in each set a shot, and once you think you've got it, come back and check with me. Let's do some simplifying. So, knowing that my end goal is standard form, I'm going to look through here and strategically try and figure out what's going to need to go first. Well, it's going to need to be an a cubed here. There's nothing I can combine it with, no like terms, so that a cubed goes there. Next up, I'm going to want to combine my a squareds, followed by my a's, followed by my constant terms at the back, knowing that standard form is my goal. Well, I've got 2a squared and negative 5a squared. That gives me the negative 3a squared. I've got negative 3a and positive 2a. Put them together, that leaves me with negative a. And then you'll notice that positive 5 and negative 5, these guys cancel out. Here is my final answer. A cubed minus 3a squared minus a, I need to state its degree as well. Well, the degree of a polynomial is determined by the degree of its first term in standard form. The degree of a cubed is 3. So this guy is a cubic polynomial. For my second one, I've got 2 instances of the distributive property. So I'm going to take that 4b and that minus sign in the second group, right, and distribute to each of my terms. Well, 4b times 3b, 4 times 3 gets me 12, b times b gets me b squared. 4b times negative 2 gets me negative 8b. Now distributing my negative, that's the same as just flipping each of my signs. So b squared becomes negative b squared, 5b becomes negative 5b, and negative 1 becomes positive 1. All I got to do now is find any like terms that I can put together. Well, 12b squared minus b squared, I take one away. I'm left with 11b squareds. Negative 8b and negative 5b, put those together, I get negative 13b's. And then I've got that plus 1 at the back. The degree of this polynomial, once again, it's already in standard form, is 2. It is quadratic. Moving on, let's do some more distributive property. So, I'm going to take my negative 4e squared f and distribute to each of my terms. Negative 4 times invisible 1 gives me negative 4. E squared times e squared gives me e to the 4th. F, I don't have any other f's to multiply with. That guy goes right there. Negative 4e squared f times negative 9f squared. Well, negative 4 times negative 9 gives me positive 36. E squared times nothing gets me my e squared, and f times f squared gets me f to the 3rd. To find my degree, you'll notice, right, e to the 4th, f to the invisible 1, e squared, f cubed, both of these have a degree of 5. The degree of my entire polynomial is 5. It is quintic. 3g cubed is now going to get distributed here in my second example. 3g cubed times g cubed, well, I've got 3 times invisible 1. G cubed times g cubed, add my powers, I get g to the power of 6. 3g cubed times negative 2g squared. Well, 3 times negative 2 is negative 6. G cubed times g squared. Once again, add my powers, g to the 5th. 3g cubed times 3, well, that's just 9g to the 3rd. Once again, I'm already in standard form. The degree of my polynomial is the degree of my first term. This guy has a degree of 6. It is hexic. Let's do a little metwet. 3h plus 5j. 3h minus 5j. Now, I could, of course, do my metwet, but if I'm eagle-eyed, I might notice that this friend is an example of a difference of squares. And the way that I know that, right, the thing at the front is the same, the thing at the back is the same, one of them's got addition, one of them's got subtraction. That immediately tells me that in my special pattern, this is going to need to be a squared, whatever the thing at the front is squared, minus whatever the thing at the back is squared. Well, the thing at the front is 3h. 3h times 3h gets me 9h squared, minus 5j times 5j would give me 25j squared. The degree of this polynomial, notice both of these have a degree of 2. Unsurprisingly, this whole polynomial should be quadratic as well. Now for 7k minus 4 quantity squared, I could recognize that this is a perfect square trinomial, but I want to do some met-wet. I feel like it. Nobody can stop me. I have agency. I'm making the video. So I'm going to multiply each term in the first factor with each term in the second. So starting off with 7k times 7k, well, that gives me 49k squared. 7k times negative 4 gives me negative 28k. Negative 4 times 7k, there's another negative 28k. And negative 4 times negative 4, there's my plus 4 at the back. Last move, combine any like terms that I see. 49k squared minus 56k plus 4. Nope, 4. Oh my goodness. Mr. Volel wants your arithmetic, my dude. This is 16 at the back. Now, the degree of this polynomial, right, it's already in standard form, is 2. Moving on. 5m squared minus 8n times m squared plus 3n. So I'm going to take my met-wet here, distribute each of the terms in my first factor to each of the terms in my second factor. 5m squared times m squared, well, 5 times invisible 1 is 5. M squared times m squared is m to the 4th. 5m squared times 3n will get me plus 15m squared n. Negative 8n times m squared will get me negative 8m squared n. And negative 8n times positive 3n will give me negative 24n squared. All I've got to do now is combine my like terms. 15m squared, take away 8m squared n's. I'm left with 5m to the 4th plus 7m squared n's minus 24n squareds. The degree of this polynomial, again, it's already in standard form. I'm going to take the degree of my first term. This guy is quartic. It has a degree of 4. Last but not least, let's take this guy. I'm going to take my 2p and distribute it to each of the factors, or each of the terms in my second factor. Take my 1 and distribute it to each of the terms in my second factor. Well, 2p times p squared, 2 times invisible 1 is 2. P times p squared is p to the 3rd. 2p times negative 3p gives me negative 6p squared. 2p times positive 2 gives me plus 4p. Now, 1 times p squared is unsurprisingly p squared. 1 times negative 3p is shockingly negative 3p. And 1 times 2 is unbelievably positive 2. All I've got to do now is add together my like terms. Well, I've got the 2p cubed right there at the front. Negative 6p squared plus a p squared is going to bring me up to negative 5p squareds. A 4p minus a 3p is going to leave me with just a positive 1p, and then my plus 2 bringing up the rear. The degree of my polynomial, once again, it's already in standard form. I'm going to take the degree of my first term. This guy is cubic. Nice! With some simplifying under our belt, let's do some factoring. Let's start with 10q r to the 3rd minus 15q squared r squared. Well, if I'm thinking about my order of operations for factoring, the first thing that I want to try is to find a greatest common factor. Between 10 and 15, notice that both of those are multiples of 5. Both of them contain at least one q. And between r cubed and r squared, following my cheat code, right, I can take the smaller exponent that I see. Both of these have at least 2 copies of r. From here, I'm going to give myself some parentheses. I need to know what's inside so that when I distribute back out, I get back to 10q r cubed minus 15q squared r squared. Well, to get from 5 to 10 in the first term, I need to multiply by 2. I have a q already, but I need to add in 1 copy of r. To get from 5 to negative 15, I need to multiply by negative 3. I need to add in 1 more copy of q to get to q squared, and my r squared is already good. Here is my factored form. Now for 25t squared minus 16u squared, notice it has 2 terms. There's subtraction in the middle. Both 25t squared and 16u squared are perfect squares. This is another instance of our difference of squares. And I know that a difference of squares always breaks down the same way. It's something times something, where the first two slots are the same, the back two slots are the same, and in the middle, one's got a plus sign, one's got a minus sign. Well, in the first slot, I need something that multiplies by itself to get 25t squared, or I can think of that as the square root of 25t squared. Well, I need 5t times 5t. And to get 16u squared, well, I need to get 4u times 4u. Here is my factored form. A little bit more. Let's take some more. 12v cubed minus 9v squared plus 4v minus 3. I look at this. I see four terms. My immediate thought is factor by grouping. So I'm going to drop a big old dividing line down my middle. I'm going to take the GCF of each part. Well, 12v cubed and negative 9v squared. Both 12 and 9 are multiples of 3. Between v cubed and v squared, I'm going to take my smaller exponent of v to the power of 2. Now in parentheses, I need something to multiply 3v squared by to get to 12v cubed. 3 to get to 12 needs to multiply by 4. V squared to get to v cubed needs an extra copy of v. Now to get from 3v squared to negative 9v squared, that just needs to be multiplied by negative 3. Now, if factoring by grouping works, I know that in my second group of parentheses needs to be 4v minus 3, but I've already got 4v minus 3, so this just needs to be multiplied by positive 1. Now that I'm here, I've got my common factor of 4v minus 3. Using my special pattern, I'm going to take that 4v minus 3 away. From both of my terms, it leaves me with the 3v squared in the first group and the plus 1 in the second. Y squared minus 4yz plus 4z squared. Well, you'll notice at both the front and the back, we have a perfect square. This guy is, in fact, a perfect square trinomial. Knowing my special pattern here, I know that this guy needs to be something times itself. It is a perfect square trinomial after all. Because there is a minus sign in the middle, both of my factors need a minus sign in the middle as well. At the front, y squared can only come from y times y. And at the back, 4z squared, well, that would have to come from 2z times 2z. Interchangeably, if I have y minus 2z times y minus 2z, well, I hope you can agree that I could also write my final answer like so. Last but not least, a cubed minus b cubed minus a squared b plus ab squared. Well, I'm going to look at this. A cubed and b cubed, they don't have anything in common. To make my factoring by grouping possible, let me rewrite this in standard form. So I'm going to leave my a cubed at the front. And then the next highest power of a here is going to be my negative a squared b. My plus ab squared would come next, and my negative b cubed at the back. Here, let me now drop my dividing line. Between a cubed and negative a squared b, you'll notice both of them have an a squared. When I take a squared out of a cubed, that leaves me with a. I take a squared out of negative a squared b, well, that's just negative b. Now, once again, thinking strategically, if there's an a minus b in my first parentheses, then an a minus b also has to show up in my second. I hope you'll agree that plus b squared here outside, if I distribute back out, will get me back to where I began. Using my factoring by grouping strategy, I've got that common factor of a minus b. Let me pull it out and put it in its own parentheses. What's left over here is that a squared plus b squared in a parentheses of its own. Very nice. Let's do some quadratics, and then we'll call it a day. C squared minus c minus 20 is my first quadratic trinomial. Well, I know that if it's factorable, a quadratic trinomial needs to be the product of two linear binomials. Because there is an invisible leading coefficient of 1, I know that my factors at the back need to satisfy a certain set of criteria. Well, I know here that these two numbers at the back, I need them to simultaneously multiply to get me to negative 20 and add to get me to my invisible negative 1. Well, a factorization of negative 20 that satisfies this criteria, at the front, it's got to be c times c. That's the only way I can get my c squared. I know that if I take negative 5 and positive 4. This will get me back to the polynomial I began with. If you don't believe me, remember that you can always check by doing a little met-wet. So I'll take c times c, which is c squared. I'll take negative 5 times 4, which is negative 20. Again, I'm really only interested in checking that middle term. Well, c times 4 gets me 4c. Negative 5 times c gets me negative 5c. 4 minus 5 is negative 1c. This is the middle coefficient that I want. Now for d squared plus 3d minus 2. Thinking again, right, about factors of 2, this could only be either negative 1 times positive 2 or positive 1 times negative 2. So if I think about my options, that means either this could be d times negative 1, or d minus 1 times d plus 2, or my other option, right, would be d plus 1 and d minus 2. Well, let's check and make sure that we like our middle term. D times 2 gets me 2d. Negative 1 times d gets me negative d. 2d minus d gets me positive d. This guy cannot be my factored form. So my only other option would be to try d plus 1 and d minus 2. Well, checking my middle term again, that d times negative 2 is now going to get me negative 2d. That 1 times d is going to get me positive d. Put them together, I get negative d. This guy does not work either. I've tried all of my factorizations and none of them work. That should immediately tell me that this polynomial is prime. Now, e squared minus 9ef plus 8f squared. So here, I know once again, if it's factorable, it should be the product of two binomials. At the front, I need to get e squared. It's got to be e times e. And at the back, I need two numbers here that are going to multiply to get 8f squared and add together to get that coefficient of negative 9. Well, if I'm thinking of factors of 8f squared, it could be negative 8f and negative f. Thinking strategically, right, a positive number at the back tells me it's got to be either positive times positive or negative times negative. Knowing that I see that minus sign in the middle, it's got to be minus minus, e minus 8 and e minus 1, f. All I got to do now is check my middle term. Well, e times negative f, this is going to get me negative ef. Negative 8f times e is going to get me negative 8ef. Put them together, we get the negative 9ef that we want. This factorization does the trick. Last but not least, let's try some where our leading coefficient is not 1. 2g squared plus 5g minus 3. Well, let me think of my options. Once again, I know that if this is factorable, it's going to be the product of two binomials. 2g squared, well, that can only be 2g times g. So let me preemptively slot those in. And I know for negative 3, either it's going to be negative 1 and positive 3, or negative 3 and positive 1. From here, all I need to do is some trial and error. Maybe I find it on the first pass, maybe I don't. Well, let me try with the negative 3 and the positive 1. Maybe it works, maybe it doesn't. Only way I can be sure is to check. So checking my middle term. 2g times 1, this is going to get me to 2g. Negative 3 times g gets me negative 3g. This guy, put them together, we get negative g. This is not my correct factorization. So let me try another version. Maybe I'll try 2g minus 1 and g plus 3. So, checking my middle term, 2g times 3 is going to get me 6g. Negative 1 times g gets me negative g. My middle term is the 5g that I want. There we go. Here's our factored form. 5h squared plus 4h minus 1. Well, 5h squared can only be 5h times h. Negative 1 can only be negative 1 times positive 1. Now it's just a question of whether or not we happen upon our correct factorization on the first go. Well, I know it's got to be a 5h and an h. Maybe I'll try the negative 1 in the first slot and the positive 1 in the second slot. Again, maybe it works, maybe it doesn't. Only way I can be sure is to check my middle term. 5h times positive 1 gets me 6, not 6, but 5h. Negative 1 times h gets me negative h. Put them together, there's the 4h that we want. This factorization does the trick. Here we go. And last but not least, 4j squared plus 8jk minus 5k squared. So 4j squared, I've got options. It could be 4j times j or 2j times 2j. But for negative 5k squared, right, it could either be 5k times negative k or negative 5k times positive k. It's got to be one of those two options. So again, maybe I happen upon the correct factorization, maybe I don't. Only way to know for sure is to check. Well, let me try the 4j and the j. I'll try the plus 5k over here and the negative k over there. Maybe I get it, maybe I don't. Let's check. Well, 4j times negative k is going to give me negative 4, just kidding. 5k times j is going to give me 5, just kidding. Put them together, this gives us just jk. This guy is not our factorization. We're just kidding with this one. Now, it turns out that the correct factorization for this guy is going to be 2j minus k and 2j plus 5k. We have a couple of other options that we need to test out. Eventually, we'd stumble on this guy. Well, 2j times 5k gives me 10, just kiddings. Negative k times 2j gives me negative 2, just kiddings. Put them together, there's the middle term of 8jk that we're looking for.